All right, question 8. An engineer wants to determine how the weight of a gas-powered car, X, affects the gas mileage, Y. The accompanying data represent the weights of various domestic cars and their mileage per gallon in the city for the most recent model year. Okay, we're going to complete parts A through D. So we're going to look at the data, and part A says find the least squares regression line treating weight as explanatory variable and miles per gallon as a response. Okay, so I'll go ahead and do this one in StatCrunch. So go to Stat, and we want to go to Regression and Simple Linear. It said the weight was X and the miles per gallon was Y, and then we have it to compute, and then we get this little output. So from our output, we can see that the intercept is given and the slope is given. As far as the directions, it says round the coefficient to 5 decimal places, and then round the constant to 1 decimal place. So that is the slope 5 and the constant to 1. So from our output, the slope, we're going to do 0.00663, and the 6 places is 0, so we'll just leave it as negative 0.00663. All right, and then our constant, we're going to round it to 1 decimal place, so 42.6, and the 1 will not round that 6 up, so just 42.6. All right, B wants us to interpret the slope and y-intercept if appropriate. So let's look at this data again. Okay, so A says a weightless car will get blank miles per gallon on average. It's not appropriate to interpret the slope. B, for every pound added, the weight of the car, the gas mileage will decrease by miles per gallon on average. It's not appropriate to interpret the y-intercept. So this one seems what we want, the slope being negative. That means as we increase the weight of the car, the gas mileage should go down by about this much on average. So again, if you go through the reading, let me pull it up in the textbook, you have to read, and it gives you a lot more information than just my little overview. But talks about rounding the slope, which you normally do to 4 decimal places. Where is it at? Talks about interpreting. There we go. So interpreting the slope. So it tells you like rise over run in algebra, but when you're doing with statistics, it's not exact. It's just a guess. So it says toward the end of the reading, instead we say over the course of the data, an increase. So based on the example here, when we do the golf example, an increase in club head speed of 1 increase the distance by this much on average. So they do on average. Sometimes it might go shorter, sometimes it might go longer. So just keep that in mind, that this is just a guess. This is not exact. So B says every pound added to the weight is going to decrease the mileage by our given slope. So 0.00663. You don't have to put negative because the decrease, word decrease, takes care of that. Doesn't make sense to interpret a y-intercept because you won't have a car with 0 weight that gets 42.6 miles per gallon. So part C, a gas-powered car that weighs 3,636 gets 18 miles per gallon. Is the miles per gallon of this car above or below the average weight? So we probably are looking at a value that's not in the table. So 3631. We don't have a 3631, but it's kind of in the middle. So it's above this, below the maximum. 36. So it's within the range, so we can predict it. So that's one thing you want to make sure. It's not far outside or too far below. And then I'll just do the basic calculator. I have my other one open right now. So what I'm going to do is we're going to take this weight, 3631, times our slope, 0.00663. We're going to make that negative, okay, and then we're going to add our intercept. So plus the 42.6. Okay, so this is giving us 18.5, and this is 18. So 18 is below the 18.5. So we would predict it to be higher at 18.5, and this came at 18, so it's a little bit lower. So the estimated average for miles per gallon for this weight is, and they want me to round to 3 decimal places, so 18.526. 18.526. The miles per gallon of this car is below average for a car of this weight, slightly below. Okay, and then part D. Would it be reasonable to use the least squares regression line to predict miles per gallon of a hybrid and electric car? Why or why not? So this is for a gas-powered car, and this is talking about hybrid or electric. So those are going to vary based on a lot of different factors. So because we're focusing on gas, we're going to say no. So no, because the absolute value of the correlation is going to be less sample size. No, because hybrid is a different type of car. Yes, so different type of car. This is for gas powered cars.